Have you already implemented sustainable plastics into your medical device? If you want to learn how we can help you save at least 1 kilogram of CO2 per kilogram of plastic, you can book a discovery call with the link in the description. Let's form a better world with plastic. Our guest today is Damian Carr. Damian is a distinguished expert in catheter innovation and globally recognized for his pioneering contribution to minimally invasive medical technology. He is the author of the Catheter R&D Handbook and the founder of Eyedea Medtech Education, where he educates medtech companies and suppliers alike on catheter technology and design. Here is our discussion. So hi, Damian, and welcome to the podcast.
Hello, Lucas. It's absolutely great to be here with you.
I love that you came on. So you are an expert in catheter technology. Tell us a bit what you do, how you came to this, and why are you so passionate about catheters?
So Catheter Technologies is essentially non-invasive keyhole surgery tools. It's, in its basic form, it's long, thin, flexible tubes. That is an overgeneralization. And the types of devices that I work on, it's not exactly just catheters, although catheters is just an easy way to describe it. It could be any sort of device that is used to go from anywhere outside of the body to anywhere inside of the body without making too much of a hole to get in there. So the likes of endoscopes, balloon catheters, neurovascular devices, even urinary catheters, anything that is making a small incision to the body or using an existing hole like mouth, ears, eyes, nose, and on the lower half of us. So I somehow got really good at designing these very complicated straws. The reason I got into this was, I'd say, the most human characteristic that I held, which was survival. I remember when I was 11 years old, ended up getting diagnosed with tuberculosis, and being the kind of mind that I was at the time and unable to really talk to anyone else around it, I had this great idea where if I grow up, or when I grow up, I'll end up designing a device to fix myself. And that'll be that problem put to bed, and it wasn't too much of a concern after that. So inevitably, went to study design, became an inventor, and went straight back into the medical device industry, where I started developing devices for customers all over the world, with the entire goal of simply just seeing cool devices, learning how they're made and how they're put together. Not much of a goal of caring about pension, wage, or any of that stuff. It was meant nothing to me. So that is how I fell into this world and how I ended up getting so passionate about it.
Yeah. We really can see that you're smiling all over your face, and you just love catheters. So tell us, what is the difference between a catheter and an endoscope, for example, and all the other devices that you mentioned? How would you categorize these, and what are the differences between these complicated straws, as you call them?
So technically, a catheter is meant to be used to move fluids in or give access in and out of the body. So it originated back in ancient Greece when Hippocrates said the word catheter, which means to send down, and this is used for urinary catheters. Now, the term kind of got a little bit broader, so endoscopes would be used. They just have a camera on the end. They may not provide access to a part of the body, but for myself, I still categorize them within the catheter world because it's the same materials, it's the same constructs, and in my head, I liked to break them down almost like they were Lego bricks, that each different part, you have a series of different blocks that you can use with it, put them together, and you can build any device. So I like the idea of overly simplifying this world, because if we can get 80% of the way there as engineers with the materials that we want to pick, the R&D is just down to that 20% of learning how to process them, how to put them together, what settings to use, what machines to use. So in regards to endoscopes, although they're not technically catheters, they use the exact same technologies that catheters use. Same with neurovascular devices, with balloon devices, or even laparoscopic devices, which would be quite rigid. But at the end of the day, it's a long, thin tube. So on that basis, I'd group them all in the same area, since we don't have one common word outside of non-invasive surgical tools.
Mm-hmm. Yeah, minimally invasive surgical tools is what I would be calling them. But like overcomplicated straws is a lot easier, and people get it a lot more.
Absolutely.
Yeah. So tell us, you started with like a little bit of the history of catheters, and you're very
Mm.
educated on that. So tell us about how did the catheters come about, and tell us about the history.
Absolutely. So started with men having problems is usually how things start from time to time. Back in ancient Egypt, around 5,000 years ago, men had the problem of getting liquid from their bladder to the outside world. So to give you a little bit of a context, there's around 8 inches of a gap between that. And we have a prostate that swells up, or your urethra could get blocked. Basically, fluid can't get out. We get really annoyed. So they started using reeds and papyrus and hollow plants that usually grow in marshy wetlands, and then take these from the ground, hollow out the inside, take away any splinters for hopefully obvious reasons, place this inside, and then you've created a portal from the inside to the outside. That absolutely worked brilliantly, so brilliantly that we actually used them for around 4,500 years before we eventually developed synthetic rubber, which was ended up creating urinary catheters. And then it just started stimming out from that as vets started testing out urinary catheters inside of horses' veins to see what would happen. And then humans picked up on this, and then humans decided, let's go testing devices on ourselves. And there's some incredible gentlemen throughout history, like Werner Forssmann, who ended up actually conducting a cardiac procedure on himself just to see if it could get done. So sticking a catheter inside of his own heart, just out of complete curiosity, and survived it. All to live the tale to tell us that we can do something similar, and then it kind of just stemmed out from there. Even the original balloon catheters, the surgeons who created them to prove they could work would actually do procedures on themselves in front of other surgeons to show this is how safe they are to use versus actually having to open myself up to spread open an artery or a vein or some place in your body that blood may not have been flowing. So very brief overlap of the history from 5,000 years ago to today.
Yeah, some quite some mad lads in there, huh?
Absolutely, and let's have more of them in the world.
Okay, good. So can you walk us through a typical surgery that you would use a catheter for?
Absolutely. So it usually goes in 2 stages. We don't tend to just jump straight into a human and conduct the surgery to try and change or fix them. First, we have to be sure something's actually wrong in the first place. But the start of these procedures work very similar. So first thing you do is, say I have a blockage somewhere along my arm. I would put local anesthetic, or hopefully someone else would do this and I wouldn't do it myself, but I put local anesthetic onto my arm. This will just kill the nerves in this area so I don't feel anything anymore. I then put in a blood signaling needle so that when blood comes out the back of it, I know I'm inside an artery. Push in a little guide wire, which is just a long, thin metal wire. It's not just that, it's a little bit more complicated. But that goes in, pull out the blood signaling needle, and then I put in an introducer and dilator, which would look something like this. So the dilator just helps it to gently glide into my body so that it's not too traumatic, it's not tearing apart my vessels. Once that's in place, I'll pull out the dilator and I'll leave in this catheter sheath. So this is an introducer. This basically acts like a doorway in and out of the body. So both procedures are the same up to this point. I have the introducer in my arm. And now the first thing I want to do is make sure that there is a blockage somewhere in my arm. So I pump in a guiding catheter, which is basically just a long straw. It's got one hole at the start, one hole at the end. There's a marker band at the very end, which we can see under X-ray, and that lets us know where the tip is. So if you can imagine, if you know where the tip of a device is and you're holding the other part of the device, you can figure out where the rest of it is. So that's in place. The next thing is I pump in contrast media, which is basically saline solution, salt water that has metal particles into it that just shine up under X-ray. I can then see under the X-ray that I have a little bit of a blockage, that the blood isn't flowing or it's narrowing or it's tapered. So this is my angiograph done. So angio kind of in the blood vessels and graph just like photography. You're just picturing what's in the blood vessels. So now I'm confident it's a blockage. Send this off to the surgeon who then looks at what they need to do, what sort of size device they need to get. We then plan another surgery, and then you get all the way into the point where you have this introducer into you. And then you will place a balloon catheter inside of that artery inflate the balloon, and it'll push the plaque and calcium and that stuff that is just built up inside of our arteries that is blocking off the blood, and it'll just push that out of the way. And then we could go in with, say, a stent, which is like a little metal cage that just holds that open, because if it gets blocked once, the reality is it's going to get blocked again. Not too many of us tend to change our lifestyle too much. So if you're in to fix a problem, we may as well make it a robust solution so that we can kind of prolong it for as long as possible. And once that is done, you just pull all the devices out, stitch the person up, or you can use some very interesting bioabsorbable pads so that they actually just blend in and absorb into your body over the space of 6 months to a year. If you do that route, you can go back into the same hole. If you stitch it, you're going to have scarring. You won't be able to go into the artery from the same point again. So just different ways of kind of closing off the wounds that we make. But that would be a very atypical procedure.
Okay. That was very interesting. So you would, during the surgery, you would have imaging devices that help you guide the catheter?
Yes. So the bit that's really hard to get your head around, or even for me to get my head around, is how a surgeon actually sees these x-rays. Because we're complicated beings on the outside. So you can imagine on the inside, if you only had a 2D black and white image of a very, very complicated arterial system. So to give you a concept, if you were to lay all your veins, arteries, and bronchi out in a straight line, you could wrap it halfway around the equator. Now take all that length of distance and wrap it up into a human-sized person, and then from one angle, take an x-ray and see, have you any clue where you're going, what direction you're going. So it's a 3D map that you're looking at, just this 2D black and white contrasted scale. So what surgeons do is remarkable. How they can confidently get a device into where it needs to go is just an absolute work of art. So this is changing in the future, but technology is not yet fully caught up with doing 3D images of the body. But when we get there, what we'll be able to unlock and what we'll be able to do will make today's devices look like simple plasters and bandages.
Have you already implemented sustainable plastics into your medical device? If you want to learn how we can help you save at least 1 kilogram of CO2 per kilogram of plastic, you can book a discovery call with the link in the description. Let's form a better world with plastic. Yeah, I see you're very enthusiastic. I love the enthusiasm. But now, just tell us, this catheter device, what is it made of? So you said it's a complicated straw. Let's break that down a little. What parts does a catheter have? And also, please tell us, because I'm all about the plastics and all about the materials. Tell us what materials are used and why.
So I split it up into 3 main sections. You have the very inside layer, and the whole job of the inside layer is to be very low friction or very lubricious. So the reason for that is we want to put other devices inside of here. And to make sure that they slide really easily, we need very low friction on one surface. So we use a liner, typically made of PTFE, most common material used. It's the third flattest material on the planet, the only material a gecko can't physically stick to. And it's used simply because we can put one device inside of another with less than the thickness of a human hair in a gap. And this device is small. This device is a little longer. Some devices are 2.5 meters long. And if you can imagine the space of a human hair between 2 devices that are going 2.5 meters long. So that's the very inside material. Then the second material, I just like to see it like the bones of the whole device. So it's typically either a spring, a braid, or laser cut hypertube. So often stainless steel, metal, reinforced scaffold layer. So this is just like the bones. And just like my arm, some parts are very stiff, but then my fingers and wrists have more flexibility. So just like a device, the bit that I'm holding is going to be going quite straight. But at the very end, this is going to bend, twist, and turn. So I need this section a little bit more flexible. Once I have those 2 layers in place, now I need to cover it over with a plastic layer. Otherwise, it's essentially a cheese grater that I'm putting into the body. So I typically use P-baxes or polyurethanes are very common materials that are used. P-bax is a brilliant material in the sense that you know yourself, over time, some materials swell, some materials shrink. They don't keep that dimensional stability. P-backs, no issues with that. It has that perfect window where it stays relatively in the middle. It also can go from really high geometers to really low geometers. So along this device, I can make it very stiff where I'm pushing and very flexible where it needs to bend around the body. If I was to do that with polypropylene or polyethylene, I just can't get those different grades or those different stiffnesses of materials to mix in well. Because from the edge, if you look at the thickness of your fingernail, that's the thickness of these two plastics coming together and joining. It's not much, so we just need to pick really robust materials. And then probably I should mention they must be biocompatible. Basically, they won't cause any harm inside the body. Your blood won't react to them. Your immune system won't flag it as something dangerous and cause inflammation and eventually infection. So for the catheters we use, if they can last in the body for around 4 weeks, materials are brilliant. That's typically the max time that you would have one of these devices in. For other devices, the urinary catheters or long-term catheters, they'd be silicone, rubber, PVC, and latex. Although PVC and latex, too much allergies, so we've kind of cut away them. So silicone and rubber. And this is because it's almost like Harry Potter's cloak of invisibility in your body. Your body doesn't recognize that the silicone is there, so it just never reacts to it. But on these complex devices, P-baxes, polyurethanes, sometimes PEEK, polycarbonate, but they're a little bit too stiff and they don't like actually working with other materials. So that's a good overview of them. We're trying to bring new ones in, but as it stands, they're the popular 80 to 90 percentile.
Okay. Yeah, I always think it's such brilliant marketing of Arkema that everybody calls it P-box because it's actually a thermoplastic polyamide elastomer. So that would be the correct scientific term, like a polyurethane, a thermoplastic polyurethane. But it's very brilliant that everybody calls it P-box. It's probably also like very, very strong competitive positioning.
It rolls off the tongue.
I don't think that anybody has similar materials that can compete. So yeah, very interesting. What you mentioned, like in the beginning, is like the PTFE topic, and I think that's accompanying you over the last, I would say, 1.5 years because of the PFAS ban. Because PTFE is categorized by the European Union as a per and polyfluorinated alkyl substance, although it's a polymer, it's a fluoropolymer, and that means that it's potentially getting banned in the future. So what's your take on that?
Banning it would be one sense, but unless you have a solution, you can't really punish what is currently saving people. So I have myself trying to find the next replacement for PFASs or for PTFE itself. So it needs to have those same capabilities. And interestingly, there might be some new materials coming out. Often it's lubricious additives that are put in with existing materials that we use. And they're not exactly replacing PTFE as it stands, which isn't a bad thing. It's actually opening up a whole new range of manufacturing methods that we can actually produce medical devices. Because PTFE, as great as it is for lubricity, that's where it stops. Stiffness, it is a very stiff material, so you are stuck with this very, very densely stiff material the whole way along your device. If we move to, say, P-backs with Everglide Plus or Propel or Mobilize on the inside, then we could actually vary that geometer the whole way along and be able to dial in the technical capabilities of the devices. So I'd love to see more alternatives. I just cannot see it being banned and putting medical devices back 20, 30 years and just saying, sorry, but we have to let these people suffer and be affected by it because we just want to eradicate PFASs. I completely stand behind the eradication or the banning of PFASs, but first we need solutions and we need more of them.
Yeah, because it's like with biocompatibility. It's always like a risk versus reward or a risk versus benefit analysis. And I think like a universal ban is not adhering to that principle. It's not like the biggest offenders get banned and then the rest is just like risk-based approach. It's like the risk of a fluoropolymer in a medical device is probably way outweighed by the benefits of saving people and not having to like have open surgery, because open surgery, like the recovery periods are like manifold higher, and the benefits really outweigh the risks here.
Yeah, to give you an idea of those surgeries, if you went in 10, 11 years ago to get a heart valve changed, you'd be in for maybe 1 to 2 weeks before the surgery. They'd be prepping you up a few days beforehand, and you would end up doing the surgery, have it open up your chest. You'd have probably 7 or 8 inches of a gap in your chest, scar wound on it, couple of weeks in recovery, and then it'd be around 6 months before you get back to where you were before the surgery, to a degree. If you went in today, you'd be in at maybe 8, 9 a.m. They do the procedure at 12 a.m. and you'd be walking out the door at around 2 p.m. A week or two later, you'll forget that it even happened. So what these materials have unlocked is just absolutely mind-blowing. And I do have a big fear that if we just try to very quickly think of a solution, we're going to push a material through that we find out in another 15, 20 years had a much worse implication for patients than what PTFE or PFAS has had. Mm-hmm. So until there is a valid solution there, a ban just doesn't make any comprehensible sense to me.
Do you enjoy the podcast? Then subscribe and rate it on your platform, and join the discussion on LinkedIn. Your feedback and comments help us improve the podcast and bring relevant topics to you. Let's form a better world with plastics. Yeah. I mean, I had Catheter R&D in the podcast, and he put it like this. It's like, yeah, we have some Peters that are criminals. And the solution is to put everybody that is called Peter in jail, just to be sure that we put all the criminals in jail. And I think it's the same thing with the PFAS, because there's like 15,000 substances, and to bunch them all together, they have vastly different properties. And there are some that need to be banned because they're bioaccumulative, they're persistent, and they're toxic. And the PTFE is none of that, because it's very biocompatible, as you probably can assure the listeners that is the case. Of course, like during the manufacturing of the PTFE, there might be some emissions into the environment, and that needs to be stopped. There needs to be rule about this, but just like banning PTFE is probably a bad idea.
Absolutely,
especially for the minimally invasive medical devices.
Now, frying pans, completely understand. Unfortunately, there's too many people out there who will take a metal spatula to a coated frying pan. So if we can't fix their use of metal spatulas in frying pans, we may just tackle the frying pan issue itself. But when it comes to medical devices, like PTFE itself, the likes of component supplies have PFAS-free PTFE mandrels. Just going to show that it's not the PTFE itself, it's actually the compounding solutions, which you enlightened me to, that is the PFASs and which is causing the harm. So by changing the process, we can still have all the advantages of using the materials, just actually tackle the real problem that's there and not just blanket over it and accuse it all of it.
Yeah. Okay. Thank you very much for your insights. But like we're here on a kind of a topic of the environmental and sustainability, and I want to switch over to my favorite topic: sustainable plastics and medical technology. What I found over the last few, I would say, months is that catheter and endoscope manufacturers actually are pretty keen on the sustainability topic. What's your take on that?
So I'm loving having seen it. I think prior to a year ago, nobody would have even brought it up as a concept. And I love seeing that there's more companies that are putting a focus onto it. It tends to be the smaller, more kind of governed, self-governed companies that I've been working with who are really keen on it. For other companies, if it goes against the cogs, they'll enlighten it, they might ask about it. But if it ends up adding 10-20% to the cost of the device, upsettingly, it gets thrown out there. But I do want to see a lot more of conscious thinking of not just building a device to fix the problem within the person, but designing a device for the whole life cycle of it. Where you get the plastics, how it's actually manufactured, how it's put into the device, and then what you do afterwards, how we actually dispose of these. So there's an untapped realm that we can go into on post-use of device or disposal of devices, rather than just putting them into biocontaminated landfill or into kind of incineration. If we have more of a push on getting sustainable materials and then being able to recycle, reuse them in a safe way, it's going to completely transform how we're developing devices. And I think companies have the fear at the moment that it's an expensive endeavor to get into sustainability. But the reality is it's going to be much cheaper in the long run because every other company is going to eventually be pushed over to this. If you have done all the work now, if you've gotten the materials, if you've gotten the experience, the understanding, and the capabilities to manufacture them, you are going to be 5-10 years ahead of what the competitors will have to chase up with.
Yeah, 100%. I can really sign off to this because many people think that sustainability is going to be a cost point. And I don't think that sustainability is a cost point. Sustainability is a strategic decision to be future proof. And, it's not only about the plastic choice. It is, of course, one of the main drivers of your CO2 footprint. However, it is also the device, because many of these devices, and you maybe also can add to this, and many of these devices are single-use devices and they get thrown out after one use. And these are very expensive, highly engineered materials that you put a lot of thought into to design them properly, to make them safe and effective. And then they get thrown out with one use. And currently they're just designed for performance and cost and not for sustainability, not for reusability, not for recycling. And I think it makes the whole medical device design more complex, which it already is very complex, but I don't think it needs to add cost. And what I've seen is people objecting to 3 or 5% a cost increase on their consumable, on their device, on their single-use device. But I don't think that this needs to be the case. I think sustainability is always misunderstood. Sustainability is always framed as ecology. It's not framed as what it actually should be. Sustainability is economy, ecology, and social aspects. And translated to medical device, it is safety and effectiveness. It's ecology, so good for the environment, and it's also profitability. I think you can really transform your business with sustainable medical devices, and you're going to have a strategic advantage if you implement it. So now rant end, please have your take.
My rant begins. So there is one endoscopic company, I'm not going to mention the company itself, but they went down the route of sustainability. So they are picking semi-recycled plastics and polymers. And going into this, they designed their device in a completely new way to how any of the competitors are doing. So on the outside, it actually ended up seeming like it would be more expensive. They've produced much cheaper device. It is a single-use endoscopic device, cheaper than what you'd actually build the traditional construct. But one of the best things that I found about their company and their style is nobody in the world can copy them. Nobody in the world knows how to use these materials the way they are. So everyone is seeing this as the pinnacle of endoscopic single-use devices that we should go to, but we can't create it for the same, or nobody can create it for the same price. So we might have seen this as an expensive endeavor going into it, but it ended up being one of the most valuable and most safest way to actually protect their devices, their style, their manufacturing long term. So that's why I'm thinking the faster you can jump on sustainability, the more you'll push yourself ahead of all the rest of the competitors.
Yeah. So number one, first, don't challenge me. I'll probably get it figured out for someone else. And number two, love it. It's exactly what I'm telling everybody. It's like sustainability is not just like add cost by using more expensive sustainable materials and then just call it a day. It's like you have to rethink the device. You have to re-engineer. You have to rethink your business model sometimes. So it's like, I mean, that would be also a very, very cool topic, and you might have a take on it. It's like outcomes as a service. It's like I provide the device, but this is a service. It's like I sell you a physical tool, and then you can keep it and throw it away afterwards. It's like I give you the device so you can perform the surgeries. Like I give you the means to deliver a service, and then then I get the device back. And then maybe I'll throw it away myself, but I can also recycle it. I can also remanufacture it, because remanufacturing is a thing in catheter technology. And Yeah, so your take on that, and then let's speak about remanufacturing for a little.
Remanufacturing single-use devices, I've never crossed the threshold of how you can re-sterilize it. In theory, you should be, but I can understand the concern of why they don't. And even why we went from reusable devices to single-use devices was there was some cases in the States where HIV was transmitted from one patient to another. And for those things, I can completely understand. But to give you an idea, one of the materials we use would be like platinum iridium. And iridium there's 4 times as much gold in the world as there is iridium. Like, this is one of the planet's rarest metals or materials that we have. And we put a bit of it in with each single medical device. It's what shines up under X-ray. And then it goes into landfill. Like, after one use, after maybe 10 to 30 minutes of use, it goes dumped into the floor. Why can't we take these and actually melt down the metals, start reusing them, see how we can separate it out? There are so many different ways, and even companies and services that could get into the life cycle after the device is used. And you could make an absolute fortune just mining these materials.
Yeah, okay. I love it. I love it because I think I can enlighten you on what Vanguard does in Germany. Do you know the company Vanguard?
Because know of them, don't know the depths.
Yeah. I know their CEO. We had her on the German podcast, and I'm still trying to get her on the English one. She's called Ulrike Marschak. She's a complete beast. And the company does the following. They're taking heart ablation catheters. You probably do know much better what that device does. And they're very expensive, like 2K or 3K, something like that. Very expensive devices. What they do is like they collect them at the hospital. They clean them. They re-sterilize them. They test them for everything. And then they put them back on the market under their own name. So they're taking like OEM names, like first source or primary market devices. They're recleaning, remanufacturing, as they call them, and then they're putting them on the market as secondary devices. And they can make them like 50% cheaper, and they save at least 50% of the CO2. And that's like that business model started because of cost, because those devices are not cheap. And they have at least like 20-30% of the devices they can't use anymore because like they're scrapped because they're damaged. They can't be remanufactured. But 70% of the devices that they're collecting, they can remanufacture them. And I think we should speak about that.
Absolutely, and it's genius. And I would love to see more devices going down this route, because one thing that I have seen is in developing countries, you might end up using a balloon catheter 10 times. Like, you can't afford to get a brand new device for each single patient. So the whole system of re-sterilizing, remanufacturing, reusing is just a no-brainer to me. Potentially commercially out there for some people, it might not make, well, actually it would make perfect sense. You've already done, as you said, 70% of devices could be reused. So 70% of the work is theoretically done. Just do that last 30% to reclean it, re-sterilize it, repackage it, and send it out there. And they should not be, with the amount of technology, the complication, the time that goes into them. And to give you an idea, Lucas, a lot of these are pretty much handcrafted, bespoke devices. You might only sell 10,000, maybe 50,000 in a lifetime. So the idea of automating these processes is just no-brainer. Doesn't make commercial sense. So we should be going, even if it is that extra 5-10% to make these more reusable and designed to be more reusable. It's a no-brainer for me. I don't know how I can even stand behind something that seems so obvious.
Yeah, but I mean, we have to speak about the elephant in the room. It's, you know, why these are single-use devices? Because of regulatory requirements. It's like you have to prove that it's safe and effective over the lifetime. So if you claim, it's like, yeah, you can probably do it like 15 times. Okay, then please tell me how you tested this and how you can prove that it's really, really safe. Because I'm going to block your certification if not. And that is kind of the point. Like in Europe, the single-use market is very strong. In the US, like the remanufacturing, the re-sterilization, that is done by the same manufacturer that bring the device on the market as a single-use device. And then their argument is like, we designed it to be single-use and you shouldn't you shouldn't use it again because we told you to, and we do not have the process in place. and the regulatory in place to prove that they're actually effective. It's your thing. And that's like the big litigation between a company such as Vanguard and like these OEMs, because Vanguard is the legal manufacturer, and there might be a name of someone else on there, and like I think they get sued 3 times a year or something like that, and they have to redo the MDR I think 3 or 4 times or whatever. It's like and they always come through, so it's very remarkable what they're doing.
Brilliant. I love seeing those examples of just one person being that David against Goliath and actually just proving that this is possible, this can be done. If we can set the example. So I have a beautiful, beautiful line that I've always held in my head where I have no desire to change the world, but to show the world that it can change.
Mm-hmm.
So simply just to make that one example that this is possible.
Yeah.
All that fear, all that concern, all that stuff that stemmed from simply just unknowing and being unaware can be taken away, and we just need an example like Vanguard to spread across the world.
Yeah. Not to get too philosophical, but it was like everybody thought that you couldn't run a marathon in under 2 hours, and then like one guy did it, and then like a lot of guys then went ahead and went below 2 hours because they knew it was possible. Just if you just believe it's possible, you can do it.
I do find that humans, our biggest problem in life is learning how to get out of our own way.
Yeah.
Simply how to do that. So similar in industry, without seeing that something could be done, we just assume it's too much of a fantasy.
Yeah, that's a very good segue, because please explain what your company, Eyedea Medtech Education, does. What do you do in your workshop, and how such a workshop works?
So I set up Eyedea Medtech Education. Started off as a design consultancy, simply to get my hands and to help out working on devices all across the world that are going to make a big difference. And then I realized a bigger difference to make would actually be putting all those skills and abilities into engineers, technicians, and essentially anyone's hands. So what I do now is I give technical workshops, very hands-on how to build these devices. And the methodology that I went around is that it doesn't matter what device you're working on, I will teach you the building blocks and all the different materials, all the different options, so you can put them together in any way you want. And I'll show you what you can do after your basic shaft or your basic device is made. If you want to drill holes in it, connect on balloons, connect on hubs, do pad printing, whatever else. So my workshops are designed within 2 days that when you walk out of it, you are pretty much just an R&D expert and will be able to put all that knowledge, all those insights straight into use and go build a device. Because when I came into this industry, you could have been 2 to 5 years designing the device itself before you get to design freeze. And my style of working is I want to get as close to design freeze in 2 weeks as possible. So what I had to do to get there is what I started training around to other people. So that's how it all started. Where it's currently at the moment is I'm after buying myself a pub in one of the most beautiful places in Ireland. I'm surrounded by mountains on all four sides, and I'm going to turn this into an education centre and prototyping lab. So I'll have people from all over the world coming in and in this pub learn how to make medical devices, and then walk next door into another bar and actually build the device we're talking about. If it's your own custom device you want to work on, but I want you walking out of this place with the device in hand, with all the materials that you need, so you can just click go, get them reordered, and actually go building the device and skip so much of the steps to get these onto the market and in saving people sooner. So that's a very quick overview.
That seems lovable. So I would love to attend some of those workshops. Maybe we can figure out something that we can do together to make catheters more sustainable. Let's talk about that after the podcast.
Absolutely, because something I really want to do, but I'm too clueless. The way I've worked this to date is if the material's approved already, I'll use it. If it's not approved and I don't know about it, I'm not going to jump down the rabbit holes. I'm not a material expert. Yeah. I don't know how to navigate the regulatory bodies. So the more I can learn from you and the more you can teach me, the more we can start changing this world.
Yeah. You know what? It's like, I'm going to enlighten you on another thing. It's like, there's no such thing as a material approval. There's only devices that are approved. It's like, of course, you can refer to the same device with the same material being used. So you can use some clinical data and stuff like that. But devices are approved, and there's not like a material that is just like biocompatible, because a material can be good to use for crutches or can be good to use for syringes, but are not good to use for long-term implantables. So it's like you have always to take into account the clinical use case and the device itself. As you said, if we have something that is like remaining in the body implanted, basically, you have to have different properties of the material than if you just have something that is like in for 10 minutes, and therefore there's no such thing as like approved for medical. That's what I can enlighten you on, hopefully.
Fascinating insight. Yeah, that clears it up so much more and explains why some materials may be good on the device in 2020, but come into 2025 and you can't use that material anymore, and that goalpost keeps shifting.
Yeah. It's like medical devices often, or has often been like, yeah, we've always used it, so never change a winning team. And but I think with your material choice, you can really have a strategic advantage, and sustainability can be a strategic advantage.
Absolutely. And we don't even know yet, similar to how they're making the PFAS-free liners with the lubricious additives, everything that they've unlocked, the whole new way of manufacturing, the whole new way of changing the durability throughout the device, of dialing in the performance of it, it's given us so much more advantages that we just wouldn't have expected. And I can only imagine the exact same will come out of sustainable materials, that they'll have different key features that we can now use in new ways that just haven't been taken advantage of before.
Mm-hmm. I couldn't agree more. So let's come to my favorite question, the last one. What advice would you like to give to our listeners in the area of catheter technology?
Initially, it can seem overwhelming. So going into it, I know that it seems like there's a lot of different aspects to go, but the first thing I'd always recommend is just get in, make one, let it be an absolute disaster, but just get hands on, make as many mistakes as you possibly can, because like most animals, you don't learn from when things go well. You learn from your traumas. So by breaking stuff, accidentally put machines on fire, not recommending that too much. But by going in and physically just getting hands on with the devices, understanding too the patients that they're going in. So too many times I'd speak to people who are working on these devices for 10, 15 years, but they've never actually reached out to someone who might have undergone a surgery. So grounded in the impact that you're making on the world, because this isn't simply just a 9-to-5 job. This is a job that has a ripple effect throughout the rest of history on how it's going to be saving lives across the world. And it's such a beautiful, passionate job and industry to be in. So take advantage of that. It's sitting at your doorstep on the understanding of what you're actually doing and the change you're bringing to the world. And I just want to see more people in this world so that they can have the same passion that I've found myself.
Yeah. So that was a very, very nice arc from the beginning where you mentioned that you got into catheters because of you being sick as a child, which is and now you mentioned you learned from your traumas. That was like the perfect close. I couldn't have scripted it better.
Getting into catheters, so eventually a catheter will get into me one day. It's an interesting way of going around it.
Yeah, very funny. So, Damian, any last words?
Lucas, I just want to thank you infinitely for having me on the podcast. I absolutely love what you're doing, and I love your passion around sustainability and what you've taught me so far about it. I think it's too confusing when we throw these buzzwords like sustainability and environmentalism on it, but you've given me the hard facts, the reality, the impact, what it does beforehand, and how it's making a difference afterwards. So endlessly indebted for all that knowledge so far, and really looking forward to hearing more.
Yes. Thank you very much. That was Damian Carr from Eyedea Medtech Education. And until the next time, Damian.
Take care, sir.
Have you already implemented sustainable plastics into your medical device? If you want to learn how we can help you save at least 1 kilogram of CO2 per kilogram of plastic, you can book a discovery call with the link in the description. Let's form a better world with plastic.